Hi, this is Dan Petrock. This is the solutions video for chapters 7 through 9 on spring 2015 in stats. So this is a hypothesis test about proportions. The null hypothesis is that 13% of the students come from single parent homes. The alternative, it's not 13%. And when we calculate the z-score here, we get 1.03. And if you look up 1.03 on our z-table, and we're looking for area above that, that's going to be 0.1515. And since it's two-tailed, we should double that. I didn't get too picky on that, but if most of you did do two-tailed and most of you did double it, if you made it one-tailed, so no, we think it's greater than, that's fine. I accepted that as well. But obviously the p-value is definitely bigger than 0.05, which means we do not reject or fail to reject the null hypothesis. That means there's not significant evidence the proportion of single-parent homes is different than 0.13. Remember, we can never accept the null hypothesis. We can either reject or fail to reject. And then the type 1 and type 2 errors, some people had some issues with this. Many people said, yes, we reject the null and say, nope, it's not 0.13, but it really is. Sometimes you forget to put it in context, or you kind of got it backwards. The type 2 errors, failing to reject the null hypothesis and say, yep, it's it is 0.13, or we're going to have significant evidence to the contrary, but it's really not 0.13. That's why it's called an error. So, and then the confidence interval, just 0.15 plus or minus 95% is a 1.96 is your z multiplier. So between 11 and 19% of the students come from single parent homes based on this data. And the question is 13% in the interval? Yes. This kind of backs up what we found out here, that we don't have evidence to say it's significantly higher than 13% or different than 13%. Number 2 is about engine life. Our null hypothesis is that it's 220,000 miles, the average. The alternative is that it's greater than. It really indicates we think it's more than. We calculate our test statistic here and we get 7.91. Well, 7.91 is extremely large, and even if we look on the t-table, see here we had 25. So if we look around row 24 on our t-table and we look for 7.9, that's way out here, that's off the chart. So the p-value is definitely way less than 0.005, or we can even say the p is about equal to 0, which means we should reject the null hypothesis because it's way less than 0.05. There is significant evidence the average engine life or mean life is it's greater than 220,000. And then if we do a 95% confidence interval, some people have an issue with the correct t multiplier. Again, there was 25 here, so we should look in row 24, and we're looking for 95%, which is the middle column here, 95%. Row 24, there it is, 2.064. Right there is our t multiplier. So we are 95% confident the true mean engine life is somewhere between 229,941 and 236,958. Is 220,000 in the interval? No. This gives us a lot of indication that the average engine life is greater than 220,000 as well. Number 3, this is comparing two population proportions. So our null is that P1 is equal to P2, and the alternative is it's not. And this is if people go to a religious service, would they stop and help people, the proportions. So we calculate our z-stat here, we get 2.18, and if we look up 2.18 on our z-table, we get 0.0146, and it is two-tailed. If you doubled it and made it 0.0292, which is less than 0.05, so we reject the null and say, yes, there is a significant difference in the proportions that would stop. And then we do a 95% confidence interval for this difference and use 1.96 as our multiplier. So we'd be 95% confident the true difference is between 1.3 and 24%, looks like. And since 0 is not in that interval, that verifies, yeah, there's a significant difference here. And then on number 4 here, this is a comparing of means, the average burn time of these two flare types. So our null is that they're equal, average, and the alternative is that the brain index was greater than, because they claim to have a longer burn time. It says right there. So we calculate our t-stat, we get 6.21. If we look up, in our degrees of freedom, typically we're going to use on these as n1 plus n2 minus 2, so it's 75 minus 2, 73. If we look in row 73 of our t-table, we don't have one, so we got to do 60 is probably the best, but the 2.66 is our largest t on this, and so that puts our p-value again very, very small, approximately equal to 0, which means we should reject the null. There is significant difference that brand X burns longer, significantly longer than brand Y. And then our type 1 would say, yep, it does, but it really isn't. It really doesn't burn longer. And our type 2 would be fail to reject and say, you know what, there's not significant difference, that there's a difference, or say that they're equal, and we're wrong. And then the 95% confidence interval, if you look at row 60 at 95%, we'll go back to that, 95%, row 60, there it is, 2.00, so that's our T multiplier. And we get a 95% confidence interval of 1.56 and 3.04 is the average difference in burn times. 95% confident that the true difference is somewhere in there. And number 5 is a paired data, so it's like we test them, score them, do some training, and score them again and see if there's a significant increase. So our null hypothesis is that the mean difference, or the mean dependent data, is going to be 0. There's going to be no difference with the training. The alternative is that it's going to actually make the scores better, greater than 0. We calculate our t-stat here, we get 3.21. There was 9 gymnasts, so if we look in row 8, 3.21 puts us right in there, somewhere between, and since it's a one-tailed test, somewhere between 0.005 and 0.01. So that's our p-value, somewhere between 0.005 and 0.01. And that means we should reject the null and say that training, yeah, it's working, it's raising scores. And then the 90% confidence interval, so if we look in row 8, 90%, so 90% is this one right here, row 8, so there, 1.86 is our T multiplier. So, and the average difference was 0.15 points. And we calculate, so we think we're 90% confident the true difference in scores will be between essentially half of a tenth and 2.5 tenths of a point. And that shows also there's a significant increase. And the last one is always kind of tricky. It says researchers with loud, or teenagers in loud music, says there was evidence. That means they rejected the null. The null hypothesis is always, it doesn't matter. No change, equality, right? The alternative is that there would be damage, or something was affecting it. So there was evidence of higher hearing loss, and that means they rejected it at the 0.05. So if we reject at 0.05, they also would reject at 0.1. So at 0.1, it's going to be the same conclusion, or yes, they would reject as well. So yep, it's significant. Now at 0.01, that's a little stronger criteria. They have to have stronger evidence to reject at the 0.01 level, but we don't know exactly where the data ended up, so that would be a maybe. If the p-value was 0.00001, yeah, they would have rejected as well. But if the p-value was 0.03, no, that would have been right in here. They would not have rejected at the 0.01 level. So, hope this video helps you prepare for the final and get ready for a test. And great job, everybody.